Hey everybody, today we are talking about data collection. Admittedly, this is a topic that would be best in a classroom where we could share ideas back and forth and maybe debate things, but that's just not possible without all of us being at home. There's not much notes for you to take here, although you're welcome to maybe copy some definitions out. And I might maybe suggest, what might be important to take down. But yeah, it's one of those days where we're not actually doing a lot of math, just talking about some principles and ideas on collecting data. So my hope is that as we go through this, as you watch this video, that you kind of at least mentally engage in a little discussion back and forth. So that being said, let's get started. Shouldn't be that long of a video lesson. So when we're collecting data, performing an experiment, there's two types, observational studies and experimental studies. So in observational studies, researchers look at situations that are already occurring and try to make inferences, which is just a conclusion based on reasoning. But the key is that they're already occurring. Like, they're just observing. They're not controlling anything. They're not administering treatment. It's just observing. So a researcher might compare two groups of people, one with members who exercise and others who don't exercise. So maybe one group is like a swim club or a track team or something, and another group is a group who might not exercise so much, but they're just observing. Like, they don't control how often these people work out or what they eat. It's just strictly observational. In experimental studies, researchers control what is going on, and then they make inferences based on those controls. So an example of an experimental study would be having two similar groups, like identical in as many ways as possible, and have one group perform rigorous exercise and the other group not, and then measure the fitness of both groups at the end of the month. So in that case, they're kind of controlling what's going on. It's an experimental study, even though both things are kind of trying to get the same information. In this example, in all experimental studies, the group that exercises is we call the treatment group, the participants who receive the specific treatment being measured. And the one that does not exercise is the control group. It's the participants who don't receive the treatment, and they're compared to the treatment group. In an experimental study, there's a greater chance of determining the cause of a particular behavior as opposed to observational, because you're controlling as many other variables as possible. It's therefore easier to make an inference if what you're doing is having an effect. Here's another visual of this idea of control group versus experimental group. So maybe you guys could visualize this. You're writing a test. Would test scores be affected by distracting sounds? So, this might be relevant to your school building. I know some spots in my school are louder than others. The walls it's not a solid wall. It might just be a divider between classrooms. Is there an advantage or is there a disadvantage to being in rooms like that? So the control group would be a class that just writes their tests normally. The experimental group would be a similar class, ideally same class, same age group, same level of academics, and then have them write the same test just with a lot louder noise, and then you can compare. Three things need to occur to determine the cause when you're doing an experimental study. So one is control. So you need to control as many aspects of the experiment as possible. Again, so if there's an effect, you know what caused it. Going back to the exercise example, if you have one group exercising rigorously for 30 days and one not, that's great. But if their diets aren't relatively similar, well, then maybe the people who exercise, it was their diets that caused the positive effects. You have to control as much as you can. If the people that didn't work out already had underlying health conditions, then that would skew the data too. So you want the groups to be as identical as possible in any way, and then have the one thing you're changing is their treatment. So this isn't always possible, and often it's impossible to do that. But we do want to control as many things as possible. So your experimental study should have some elements of control. It should have some elements of randomization too. When the groups are chosen, the subjects need to be randomized so that no biases occur in any of the groups. Going back to the exercise example, if you have choosing your groups, if the group you choose to administer the exercise to are all the people, say, over 50, and the people who don't exercise are all under 50, well, then you're not sure what is causing the effect, right? So you don't want any bias in any individual group. The group should be chosen randomly. And the last thing is replication. So even though the groups are random, if the researchers were to repeat this experiment, the groups should be similar in makeup so that the changes from one group to another are easier to detect. So those are the three things you need: control, randomization, replication for a good experimental study. So let's just have a little conversation, or at least engage mentally and think about this. So which type of study, I'm going to give you guys a couple cases. Which type of study are we looking at? For each one of these, think about whether it is experimental. Think about whether it is observational. If it's experimental, what do you think the control group is? What do you think the treatment group is? What's the effect being studied? And if it's an observational study, what are some things that could cause the effect to happen? So here we have people with headaches are randomly divided into two groups. One group gets pain medication, the other does not. 1 hour later, the participants are asked about their pain. All right, so if you want to pause the video and think about this for a bit, and then unpause it when you're ready, that would be fine. But this is an example of an experimental study. So we have, if we talk about our three elements, in this case, we have control. One group gets the medication, one group doesn't. We also have, we can't tell if the two groups have a similar makeup. However, there is some randomization, keyword randomly. So we have two of those three criteria. So this is a decent experimental study, a very basic one, but it's a pretty decent one. Consider the next case. So let's say you go to all of the houses in your neighborhood and ask whether they use fertilizer on their lawns. You then check to see if their grass is green. So think about this one, and you can unpause the video when you're ready. So if you think it's experimental, what aspects are met of those three. If you think it's observational, which ones aren't? Well, this is an observational study because you're essentially just observing. You're checking if their grass is green. You aren't controlling which houses get fertilizer. You're not controlling how much fertilizer, what type of fertilizer. It's not random. You're going to all the houses on your street. You're not, and as far as replication goes, you go to different streets in your town. Well, some areas of town, like socioeconomically, some people might not have the money to spend on fertilizer. But if you're in like an upscale suburbs, like maybe everybody just does fertilizer, just what they do. So really, none of the three criteria for an experimental study are met. This one is observational. You still might be able to get some information about whether fertilizer works or not, but it's purely observational. Next, we're going to talk about survey questions and designing a good survey. Conducting surveys is one way to collect primary data. You've probably done some surveys in your time. Primary data is just data you collect directly. It's not from a source. That would be secondary data. Like if you go research some numbers or some figures online, that'd be secondary data. But if you're collecting it yourself, it's primary data. Surveys are less controlled than experiments, but a well-written survey can still provide useful information. So I've given you guys a survey I lifted from the textbook I use, and we're just going to discuss some improvements that can be made. A lot of improvements, actually. So first thing, is the survey anonymous? And why might anonymity be important? Well, the survey is not anonymous. It asks for the person's name. And generally in surveys, anonymity might be important because surveys might be collecting personal information. People who know a survey is not anonymous, they might hold back on some of their responses, not sure who's going to be looking at this information and not wanting it to be traced back to them, especially in this day and age with online privacy and whatnot. So yes, surveys should be anonymous. Let's look at the choices for ages. Are they appropriate and clear? If not, how could we fix this section? And why is this information important to collect? Maybe if you want to pause the video and have a look at those age ranges, maybe you can think of a few issues. I can think of a couple off the top of my head. So if you notice that there's some overlap, like if you're 12 or if you're 16, which box are you going to check? It's not really clear. Also, the 12 to 16 box is larger than the 10 to 12 box in terms of interval range, which is larger than the 16 to 17. So there's many issues within that one. Demographics, this idea of ages, among other things, can be really important. It can reveal trends within the population. So it's not a bad idea to get people's ages, as long as it's not anonymous. Oh, I don't think I want red. Just get out of here, face. Let's get blue here. So if you were to fix this section, there's nothing wrong with just 10, 11, 12, up to 17, 18, and then like maybe having an option for 19 plus, or you could just have the people write down their age. Lots of ways to fix that. But yeah, you want to have at very least equal ranges. You don't want any overlap. So that's just very confusing, that question there. Is number one a leading question? So a leading question is a question phrase to influence the way a person answers. So let's read question one. Would you like to have the freedom to use your cell phone in class? Well, that sounds really good. I'm already like, well, yeah, I want freedom to use. I like freedom. Freedom is good. Or would you rather be alone with no communication? Well, like I don't want to be alone. That's really negative. So I hope you guys would agree that this question is very leading. It's meant to, I would say most people would be influenced to select yes, cell phones. It's clearly a biased question. If we were to fix this question, we might just say, do you think we should have cell phones in the classroom or not? Just ask the question, right? So yeah, leading questions are not good in surveys. Do any questions provide a limited number of options? Well, I think the obvious answer to that one is look at question two. What's your favorite? What of the following is your favorite subject? Math, English, drama. Well, obviously there's many other subjects. This can lead to bias as well. This is almost like a leading question as well, because it's leading people to select math, English, and drama when people can't select physical education or history or geography or art. So if you were to rewrite that question, you might just say, what is your favorite subject? And then have people state what their favorite subject is. Does the survey ask any personal questions that people might not prefer to answer? Well, you might actually have a couple of opinions on this one. Generally, asking questions about religion is unethical. You're kind of you're excluding a large portion of people that might attend a different place of worship. So in general, not a great idea to include questions like that. Some people might not prefer to answer the gender question as well, or at the very least, we can make the gender question more inclusive as well. So you might have other opinions on that question as well. Sorry, that's just my dog. Yeah, let's move on. Is the rating scale in 4 a well-written scale? If not, rewrite it. So how do you like the new cafeteria menu? Pretty good, good, great, fantastic, awesome. Well, I don't know about you, but those are only good options. Side note, the White House last year actually had a survey on the government website about how well of a job President Trump was doing, and it was like this. It only had these kind of options. So if you were to rewrite the scale, you might have reworded like the new cafeteria menu is great, and you could have strongly disagree, neutral. You've seen questions like that: agree, strongly agree. Or you could have, hate it, don't prefer it, neutral, it's good, it's great. But I think the way it is, obviously, with no negative ratings, no neutral ratings, that's not good. And also, like, is fantastic better than awesome? I don't actually know. Like, how do you quantify that? Question 5 asks for an opinion about 2 things in one question. So, the problem with this one is, how do you like the new school logo and mascot at the school? And, what if you like the new logo but don't like the mascot? Or what if you don't like the new logo but you like the mascot? It's not a really well-designed question. Maybe you would break this up into 2 different questions where you ask about the school logo and you ask a lot about the mascot. So, on the surface, if you just quickly looked over the survey, it looks well organized, it looks neat, it looks well put together. But when you look at all the details, you can see there's a lot of issues. So this is just some things to keep in mind if you have to create surveys on your own. The last thing I want to talk about is bias. Bias occurs when there's a prejudice for or against an idea or response. So if you look at question 2 is clearly biased. Whoever designed the survey probably feels pretty strongly about keeping the cell phones in the class. Leading questions are one example of bias, and you'd like your data collection and your surveys to be free of bias. We're going to look more at types of bias later on, but a leading question is one example that you've been introduced to. So later on, when we talk about bias in more detail, you kind of have a general idea of what it means. All right, guys, that's it. Pretty easy, pretty light lesson. No real heavy math, just some discussion on some concepts. Again, this would have been great to discuss with you guys in person. And it'd be fun actually to get you guys to create surveys and kind of collect that data as well. But from where we are, it's kind of impractical. So I've got a PDF of these questions on Brightspace, or maybe you have your textbook with you. And these questions shouldn't take too long at all. You're just looking at whether, making sure you know what observational versus experimental studies are, know those 3 criteria for being an experimental study, which is control, replication, randomization. And then looking at a few survey questions and just reflecting on, can they be fixed up, and just maybe fixing those survey questions up. So it should be pretty light, but the big takeaways for today, and maybe if you were not taking notes, just maybe flipping back, talk about some key ideas for you to get in there. The big idea is you should know the difference between observational and experimental. You should know what a control group is, a treatment group is. You should know the 3 things needed to determine the cause for a good experimental study: control, randomization, replication. And then You should know what a leading question is, know what bias is, and then in general, just be able to take the discussion we've had and kind of critique a survey, and hopefully make up a decent survey yourselves. So yeah, have a look at those questions. They shouldn't take too long, and that's it for today, guys. I hope you have a good one, and we'll see you guys soon.